Okay, dear students, welcome back to online classes. Dear students, in this class, I will discuss another one JE model question paper. Now, directly move to the first question. The first question is when plate voltage in diode value is increased from 100 volt to 150 volt, then plate current increases from 7.5 milliampere to 12 milliampere. The dynamic plastic resistance will be, we know the formula. When the plate resistance in diode value is increased, the plate resistance, we know that formula, that is rp is equal to, here when plate voltage in diode value is increased, plate resistance or plate voltage means the change in the voltage, that is delta v into p. Plate voltage increase from 100 volt to 150 volt, then plate current increase from 7.5 milliampere to 12 milliampere. Plate current, that is delta into ip. Plate voltage, plate current, then the dynamic plastic resistance will be R is equal to V divided by I. Here now substitute the values here. The plate resistance or plastic resistance Rp is equal to the change in the voltage, that is 150 minus 100 divided by change in the current 7.5 milliampere to 12 milliampere, that is 12 minus 7.5 milliampere means 10 to the power of minus 3. It is equal to 150 minus 100, this is 50. 50 divided by 12 minus 1.5, that is 4.5 into 10 to the power of plus 3. 50 divided by 4.5, that is 11.1 into 10 to the power of 3. The SI unit of resistance is ohm. 10 to the power of 3 is kilo. Then 11.1 kilo ohm. Option A is the right answer. The second question is pressure versus temperature graph of an ideal gas of equal number of moles of different volumes is plotted as shown in the figure. Mark the correct alternative. Pressure versus temperature. Here this is along y-axis we have taken the value pressure, along x-axis we have taken the value temperature. The pressure versus temperature of an ideal gas of equal number of moles of different volumes. Here this is for 1, 2, 3 and 4. Mark the correct alternative. Mark the correct alternative. From an ideal gas equation, we know the formula PV is equal to mu into RT, or pressure P is equal to mu R divided by V into T. Here compare this equation with, it is in the form of y is equal to m into x. Then we get the graph like this, that is when we draw the pressure versus temperature diagram. Here theta is the certain angle, volume is the constant. From using this graph we know the formula slope tan theta is equal to m is equal to mu r divided by v. M is equal to mu r divided by v, that is the volume is inversely proportional to its angle tan theta. Here it means that the line of smaller slope represent greater volume. The line of smaller slope represent the greater volume of gas. For this given problem, here in this figure, points 1, 2 are on same line, so they will represent the same volume, that is V1 is equal to V2. and similarly point 3 and 4 on the same line, so they will represent the same volume. Here for this, that is V3 is equal to V4, but V1 is greater than V3, or it is equal to V4, or V2 is greater than V3, or it is equal to V4. As slope of line, as slope of line 1 minus 2 is less than 3 minus 4. Therefore, the option A is the right answer, or 1 is the right answer. The third question is, if two balls of same metal weighing 5 gram and 10 gram strike with a target with the same velocity, the heat energy so developed is used for rising their temperature alone, then temperature will be higher. Two balls of same metal. Now I consider this is the first ball and this is the second ball. Here this first ball weight is 5 gram and this second ball weight is 10 gram. Strike with the target. Here this is the target. Strike with the target with the same velocity. The heat energy is developed is used for rising their temperature alone, then temperature will be higher. Here for we know the formula, energy E is equal to half mv square. This is the kinetic energy formula. Then when it is converted into heat from using specific heat equation, again we reconstruct this is equal to m into c into delta T. Here the delta T is inversely proportional to its velocity. It shows temperature is independent of the mass of the ball. It does not depends on mass of the ball. It is independent of mass of the ball, and that's why it is equal for both the balls. It is equal for both the balls. Option 3 is the right answer. The next question is, a spherical liquid drop. A spherical liquid drop of radius r is divided into 8 equal droplets. If surface tension is T, then work done in this process will be. Here we know that formula, the work done in the surface tension W is equal to 4 5 r square into T. 4 5 r square into T, then r whole to the power of 1 by 3 minus 1. Here the radius is the spherical liquid drop of radius r is divided into 8 equal droplets. Then we write this equation, W is equal to 4 5 r square into T. Here 8 equal droplets, 8 whole to the power of 1 by 3 into minus 1. Therefore the surface tension is T, then the work done in this process W is equal to 4 5 r square into T. W is equal to 4 5 r square into T. Option 2 is the right answer. The next question is, this is question number 5. G is the acceleration due to gravity at Earth's surface. This is the Earth's surface. G is the acceleration due to gravity. K is the rotational kinetic energy. K is the rotational kinetic energy. Suppose Earth radius decreases by 2%. R is the Earth radius. This Earth radius decreases by 2%, keeping all other quantities same. Keeping all other quantities same. We know the formula, acceleration due to gravity on the surface of the Earth, that is G is equal to Gm divided by R square, and K is equal to L square divided by 2I. If mass of the Earth as well as its angular momentum remains constant, then G is inversely proportional to R square. Inversely proportional to R square, and K is inversely proportional to R square. It means if radius of the Earth is decreased by 2%, if the radius of the Earth is decreased by 2%, then G and K K value. Both are increases by 4%. Both are increases by 4%. Option 1 is the right answer. Next question is, if c is the speed of electromagnetic waves, c is the speed of electromagnetic wave in vacuum, it's the speed in a medium of dielectric constant k and relative permeability mu r is. Here speed of light of vacuum is given by c is equal to 1 divided by root of mu naught into epsilon naught, and that of equation in another medium is, that is phi is equal to 1 divided by root of mu into epsilon naught. Then the ratio of these two values is, that is c divided by phi is equal to root of mu into e divided by mu naught into epsilon naught, or mu divided by mu naught value is, that is mu r, e divided by epsilon naught value is k. Therefore phi is equal to c divided by root of mu r into k. Phi is equal to c divided by root of mu r into k. Then the option 2 is the right answer. The next question is, if the length of the second pendulum is increases by 2%, calculate how many seconds it will lose per day. How many seconds it will lose per day. Here, if the length of the second pendulum is increases by 2%, we know the formula. T is equal to T into root of, that is 1 plus 2L divided by 100 divided by L. Now substitute the values. T into 1 plus 2 divided by 100. 2 divided by 100 whole to the power of 1 by 2. Here it is equal to 2%. 2 into 1 plus 1 divided by 100. Therefore, the T dash minus T is equal to 2 divided by 100 is equal to 1 divided by 50 second, and 1 divided by 50 divided by 2 into 24 hours 60 minutes into 60 seconds, we get the answer 864. Option 4 is the right answer. A particle carrying a charge equal to 100 times. A particle carrying a charge equal to 100 times the charge on an electron is rotating per second in a circular path of radius 0.8 meter. The value of magnetic field produced at the center will be mu naught is equal to permeability for vacuum. We know the formula. I is equal to Q divided by T. It is 100 into E. Charge equal to 100 times the charge on the electron, that is 100 into E. Then magnetic field at the center, that is mu naught divided by 45 into 25I divided by R. It is equal to mu naught divided by 45 into 25 into I is 100 into E divided by R. Then the magnetic field at center is equal to mu naught into 200. 100 into 2 is 200 into electron value 1.6 into 10 to the power of minus 19 divided by, here 5 value cancel, 4 into the radius value is 0.8. when you are calculate, finally we get the answer. It is in the order of 10 to the power of minus 17 mu naught. Magnetic field BC is equal to 10 to the power of minus 17 mu naught. 10 to the power of minus 17 mu naught is option 1 is the right answer. Then the next problem is, a body is sliding down an inclined plane having coefficient of friction 0.5. If the normal reaction is twice that of the resultant downward force along the incline, the angle between the inclined plane and the horizontal is angle between the inclined plane and horizontal is when the resultant downward force along the inclined the resultant downward force along the incline is equal to mg into sin theta minus mu cos theta, and reaction is the normal reaction is equal to mg into cos theta. Here mg cos theta is equal to mg cos theta is equal to 2 mg into sin theta minus mu cos theta, because if the normal reaction is twice of the resultant downward force, here this is the resultant downward force, the normal reaction is, this is normal reaction is twice of the resultant downward force, then I write this equation mg into cos theta is equal to 2 mg sin theta minus mu cos theta. When you are solving from using trigonometric equation, we get theta is equal to 45 degree. Option 2 is the right answer. The next question is here. Assume photo emission to takes place. The factor by which the maximum velocity of the emitted photoelectrons changes when the wavelength of the incident radiation is increased 4 times. According to the Einstein photoelectric equation, hc divided by lambda is equal to work function plus the maximum kinetic energy. It is in the form of E is equal to energy is equal to work function plus kinetic energy, on mu is equal to work function plus kinetic energy. This is the maximum kinetic energy. Here work function, this is negligible in comparison. Therefore hc divided by lambda is equal to v maximum, or velocity v square maximum is inversely proportional to its wavelength, then v maximum is inversely proportional to root of its wavelength. On increasing the wavelength lambda to 4 lambda, v or the speed is becomes half. Option 1 is the right answer. Then the next question is, what is flux? Passing through the shaded surface of a sphere. The flux passing through the shaded surface of a sphere when a point charge q is placed at the center. Radius of the sphere is r. Here, if for solid angle subtended by BCD, here the angle is 60 degree. And in this problem, when we draw the triangle, here this is A and E. This point is taken as a C, and this is B, and this is D. Here alpha is 60 degree. Solid angle subtended by ABDE. Here this is the what is flux passing through the shaded surface. Then W from AB, it is from ABCDE minus from BCD is equal to, this is 2 phi minus 5. Phi is 180 degree. 2 phi minus 5. Therefore flux through this ABDE is, from using the Gauss law, electric flux is equal to Q divided by epsilon naught pi divided by 4 phi. It is equal to Q divided by 4 into epsilon naught. Option 3 is the right answer. The next question is, a force of 5 Newton. A force of 5 Newton acts on a 15 kg body. A force of 5 Newton acts on a 15 kg body initially at rest. Here, this is 15 kg body. A force of 5 Newton acts on this body. This is 15 kg. It is initially at rest, means initial velocity u equal to 0. Work done by the force during the first second of the motion of the body is, we know the formula, W is equal to F into S. Then F is equal to, S is equal to, it is in the form of S equal to ut plus half at square. Initially it is at rest. Then I write this equation, 1 divided by 2 into 8 square. Therefore W is equal to F into 1 divided by 2 acceleration, F equal to ma, a is equal to F divided by m into t square. F divided by m into t square. Then W is equal to F into F square into t square divided by 2m. W is equal to F square into t square divided by 2m. Then force is 5 Newton. 5 into 5, that is 25 into 1 square during the first second, that is 2 divided by mass is 15, then 25 divided by 30, this is 5 by 6 joule. Option 4 is the right answer. The next question is, in a hydrogen discharge tube, in a hydrogen discharge tube, here it is observed that through a given cross section 3.13 into 10 to the power of 15 electrons are moving from right to left, and 3.12 into 10 to the power of 15 photons are moving from left to right. Hydrogen discharge tube. Now I consider this is the hydrogen discharge tube. It is observed that through a given cross section area is, this is 3.13 into 10 to the power of 15 electrons are moving from right to left, and 3.12 into 10 to the power of 15 protons are moving from left to right. What is the electric current in the discharge tube and what is its direction? Here we know the formula, I is equal to Ne into QE. Ne into QE plus Np into Qp. Here Ne into QE, this is for electrons, and Np plus Qp, this is for protons. This is for protons. Then here, when you are substituting these two values, this is nearly about, the answer is 1 milliampere towards right. 1 milliampere towards right. Option 2 is the right answer. In an ideal gas heat engine, operates in a Carnot cycle between 227 degrees Celsius to 127 degrees Celsius. It absorbs 6 into 10 to the power of 4 joule at high temperature. The amount of heat converted into work is, efficiency eta is equal to 1 minus T2 divided by T1. Therefore 1 minus T2 is 127 plus 273. Then we get 1 minus 400 divided by T1 is 500. Here we get efficiency is 1 by 5, and amount of heat converted eta is equal to W divided by Q. Here efficiency eta is 1 by 5 is equal to W divided by Q. Then W is equal to Q divided by 5. That is 6 divided by 5 into 10 to the power of 4. It is equal to 6 by 5, 1 by 2 into 10 to the power of 4 joule. Option 1 is the right answer. Then question number 15. The graph between the instantaneous concentration of a radioactive element and time. radioactive element and time. We know the formula. N is equal to n naught e to the power of minus lambda into t. It is the radioactive formula. N is equal to n naught e to the power of minus lambda into t. We know the exponential curve. We know the exponential curve here. This curve cannot touches this line. When you draw the graph between n versus t, here it gives n is decreases exponentially with the time. Or here dn divided by dt is equal to minus lambda into n. Option 3 is the right answer. The minimum velocity with which a car driver must traverse a flat curve of radius 150 meter. What is the coefficient of friction? 0.6 to avoid skidding. Here, the friction will provide the required centripetal force. Friction will provide the necessary centripetal force. And R is the radius. The flat curve of radius R is, that is 150 meter. What is the coefficient of friction? That is mu k. Coefficient of friction to avoid that skidding. Here the car exerts the force on this here, that is normal reaction, and certain force is acting on this, that is weight mg, that is weight md. From the force acting on that car is, from using centripetal force formula, that is F is equal to mv square divided by r. This is equation number 1. If the car does not skid, then the friction should be static in nature. Therefore, the force is less than or equal to mu into n. Then again that friction is, that centripetal force me square divided by r is less than or equal to mu into normal reaction, that is mg. Therefore, V is equal to root of mu into rg. Here the maximum permitted velocity V is equal to mu of r into g. Now substitute the values. Root of mu is equal to, that is 0.6, r is 150, and acceleration due to gravity, there is no digit values in this. That's why I will take 10, 150 into 10, 1500 into 0.6, then we get V is equal to 30 meter per second. Option 2 is the right answer. Then the next question is, a barometer tube reads 76 centimeter of mercury. If the tube is gradually inclined at an angle of 60 degree with vertical, keeping the open end immersed in the mercury reservoir, the length of the mercury column will be, here from when the barometer tube reads 76 centimeter of mercury, if the tube is gradually inclined, this is theta equal to 60 degree. Then for this problem, here this is mercury, a barometer is immersed here, which makes a certain angle, theta is equal to 60 degree. Here H, this is tube is gradually inclined at an angle 60 degree with vertical, keeping the open end immersed in the mercury reservoir. This is reservoir. The length of the mercury column, that is here cos 60 degree is equal to H divided by L. Then L is equal to H divided by cos 60 degree. Height is 76 centimeter divided by cos 1 by 2. Then L is equal to 152 centimeter. Option 4 is the right answer. Then the question number 18. Two wires of same material have lengths in the ratio 1:2 and their radii are in the ratio 1:√2. If they are stretched by applying equal forces, the increase in their lengths will be in the ratio. Here, length is equal to F into L divided by 5 r square into y. L is inversely proportional to L divided by r square. F and y are constant, then the ratio is L1 by L2 is equal to L1 by L2, then R2 divided by R1 whole square. L1 by L2 is equal to L1 by L2 R2 divided by R1 whole square. Therefore, if they are stretched by applying equal forces, increase in their lengths, that is 1 is to 2, increase in their lengths, R2 divided by R1, that is root 2 into whole square. Therefore, L1 by L2 is equal to 1 is to 1. Option 1 is the right answer. Then the question number 19. Question number 19. An equilateral triangle ABC. This is equilateral triangle ABC formed from a uniform wire has two small identical bits initially located at A. The triangle is set rotating about the vertical axis A. Then the bits are released from reset simultaneously and allowed to slide down, one along AB and other along AC, neglecting frictional effects. The quantities that are conserved as the bits slide down. In this problem, as bits slide along, then the moment of inertia of this system is increases, and according to the angular velocity decreases, but angular momentum of the system remains conserved. Therefore, the external torque on this system is zero. Also, the total energy of the system is remains conserved because there is no dissipative force. Therefore, the total angular momentum and the total energy is, as the quantities are conserved. The option 1 is the right answer. Then the next question is a tuning fork of frequency. A tuning fork of frequency 392 Hz resonates with the 50 centimeter length of a string under tension if length of the string is decreased by 2%, keeping the tension constant. The number of beats here and the string and the tuning fork made to vibrate simultaneously. Here the n is directly proportional to L divided by I. The tuning fork of frequency is 392 Hz, resonates with the 50 centimeter length of the string under a tension T. If the length of the string is decreased by 2%, therefore, here delta n divided by n is equal to minus delta L divided by L. Length is decreased by 2%, then frequency is increases by 2%. Therefore, n2 minus n1 divided by n1 is equal to 2 divided by 100, or n2 minus n1 is equal to 2 divided by 100 into n1. Therefore, n2 minus n1 is equal to 2 divided by 100 into n1 is, that is 392. It is equal to nearly 7.8, or the value is 8. Option 2 is the right answer. Okay, dear friends, the next topic of this question is, okay dear students, the next question is question number 21. This is numerical problem. This is numerical problem. A thin copper wire of length L meter increases in length by 2% when heated through 10 degrees Celsius. What is the percentage increases in area when a square copper sheet of length L meter is heated through 10 degree Celsius? Here, thin copper wire of L meter increases by 2%. Suppose if you consider this is here, L is the length of the wire, A is equal to, this is length of the wire, it is increases by 2%. What is the percentage? increase in area when a square of copper sheet of length L meter is heated through a 10 degree Celsius. Then the change in the area, the change in the area. Here the thin copper wire of length L. L is the thin copper wire. Initially, the change in length, that is dl divided by L, is that is 2%. 2% means that is 0.02. Area is equal to L square. We know the formula. Here the change in that area of that copper sheet, that is dA divided by A is equal to dA divided by A is equal to 2 into A is equal to L square. L square is, that is 2 into dl divided by L. Now the change in the area dA divided by A is equal to 2 into dl divided by L. dl divided by L is, that is 0.02. 0.02 or 2 into, this is 2%. 2 into 2 is, that is 4%. Option A is the right answer. Or for numerical value here, write here the answer, the 4%. The 4%, that is the percentage increase in area when a square copper sheet of length L meter is heated through 10 degree Celsius. The exact accurate answer is 4%. Then the next question is the initial velocity of a particle. The initial velocity of a particle is u. U is equal to 4I plus 3z. U equal to 4I plus 3z, and it is moving with the uniform acceleration. It moving with a uniform acceleration. A is equal to 0.4I plus 0.3j meter per second square. The magnitude of its velocity, the magnitude of its velocity after 10 second is, after 10 second is, there is no option. Now we have to find the answer. Here the initial velocity, that is v is equal to, we know the formula, v is equal to u plus at, the magnitude of its velocity equation. But here for this problem, u is equal to, that is 4I plus 3j. U equal to 4I plus 3j, and the acceleration is, that is 0.4I plus 0.3j. 0.4I plus 0.3j into time t is after 10 second. Then we get the answer, v is equal to, this here is 0.10 into 0.4 is 4, and 10 into 0.3 is 3. Then 4 plus 4 is, that is 8I plus 3 plus 3 is, that is 6j. When you are multiplying these two values, we get v is equal to 8I plus 6j. The SI unit of velocity is meter per second. Then the x and y components of, the x and y components of here, v and vx is the velocity along the x-axis, that is 8 meter per second, and velocity along the y-axis is, that is 6 meter per second. This is for x and this is for y. 6 meter per second. Then the magnitude of its velocity is, that is v is equal to root of, v square x plus v square y is equal to root of v square x, that is 8 square. V square y is 6 square. Therefore 8 square value is 64. 64 plus 36. 64 plus 6, 70. 70 plus 30 is 100. Root of 100. Root of 100. Then the answer is 10 meter per second. Here the magnitude of its velocity after 10 second is, that is 10 meter per second. Then the third problem is here, 23rd problem. A 2 meter wide track, 2 meter wide truck, sorry, wide truck, this is truck. A 2 meter wide truck is moving with the uniform speed. V naught is equal to 8 meter per second after Along a straight horizontal road, a pedestrian starts to cross the road with the uniform speed v. When the truck is 4 meter away from him, what is the minimum value of v in meter per second so that he can cross the road safely? Here, when the man start crossing the road at an angle theta with the roadside for safe crossing, the condition is the man must cross the road by the time the truck describes the distance. By the truck describes the distance. Here, 2 meter wide truck. Here, this is 2 meter. Moving with the uniform speed 8 meter per second. Along a straight horizontal road, a pedestrian starts to cross the road with the uniform speed when a truck is 4 meter away from him. When a truck is 4 meter away here, this distance becomes 4 meter here, which makes a certain angle theta. Here it is moves from point A to B. Point A to B. In this problem, for safe crossing, the condition is that man must cross the road by the time the truck describes the distance. Describes the distance, that is 4 plus 2 cot theta. This is the standard formula. 4 plus 2 cot theta. Therefore, 4 plus 2 cot theta divided by 8 is equal to 2 divided by sin theta. This is sin theta means opposite divided by hypotenuse divided by phi, or phi is equal to, what is the minimum value of phi? Phi is equal to 8 divided by, phi is equal to 8 divided by 2 sin theta plus cos theta. For minimum value of phi, that is dv divided by d theta is equal to 0, or here it is minus 8 into 2 cos theta minus sin theta divided by 2 sin theta plus cos theta whole square. This is equal to 0. Here in this problem, when you are applying here, or you can write, this is also you can write, it is in the form of 2 cos theta minus sin theta is equal to 0, or sin by cos is tan theta is equal to 2, or sin theta is equal to 2 divided by root 5, or cos theta is equal to 1 divided by root 5. Then you get phi minimum is equal to 8 divided by 2 into 2 divided by root 5 plus 1 divided by root 5. We get the answer, that is 8 divided by root 5. 8 divided by root 5 exact value is 3.57 meter per second. That's why the minimum value of v in meter per second, that he can cross the road safely with a velocity of 3.57 meter per second. Then the next problem is, that is question number 24. A particles p and q of mass, particles p and q of mass 20 gram and 40 gram respectively are simultaneously projected from the points A and B on this road. Here p and q of mass 20 kg and 40 gram, 20 gram and 40 gram respectively are simultaneously projected from the points. Here this is projected from this point A, and this is projected from this point B. This is Q and this is P. Both are moving simultaneously. P is moving with an angle theta 45 degree. B is moving with an, here this is Q, with an 135 degree. Here with the horizontal AB as shown in the figure, and each particle has initial speed of 49 meter per second. Initial speed is 49 meter per second. This is initial speed. Then the separation of AB is, the distance between point A to B is 245 meter. Both particles travel in the same vertical plane and undergo collision. After the collision, P is retrace its path. how much time after the collision does particle q take to reach the ground? Here, time taken to reach the ground when the particle p is retraced to its original path. That value is, now I am going to calculate. You know the formula. Height of the projectile, that is u is h is equal to u square sine square theta. U square sine square theta divided by 2z is equal to initial velocity, that is 49. Moving with the 49 whole square, then sine square 45 degree divided by 2 into 9.8. Here h is equal to 45 and 49 into 49 and sine square 45 degree. When you are substituting all these values, we get h is equal to 61.25 meter. And time taken by q to reach the ground, that is time t is equal to root of 2h divided by g. Now substitute the values in this equation. Root of 2 into h value is 61.25. Root of 2 into 61.25 divided by 9.8. Then t is equal to 3.53 second. T is equal to 3.53 second. Then the next problem is, this is the last problem. If two balls of each mass 0.06 kg m moving in opposite directions with a speed of 4 meter per second collide and rebound with the same speed, then calculate the impulse in kg meter per second imparted to each ball due to other, that is kg meter per second. The mass is equal to 0.06 kg and velocity v is equal to 4 meter per second, and rebound's velocity is, this is velocity, then rebound velocity is, that is minus 4 meter per second. Rebound with the same speed means, that is minus 4 meter per second. We know the formula. Impulse is equal to, that is the change in momentum. Impulse is equal to change in momentum. Change in momentum means initial momentum minus final momentum. Initial momentum, that is 0.06 into 4 minus, then the final momentum 0.06 into v value is, that is minus 4. The initial momentum you can also taken as u, and this is v. Here the change in momentum I is equal to 0.06 into 4, that is 0.24 minus 0.06 into minus 4, that is minus of 0.24, minus of 0.24. The impulse I is equal to 0.24 plus 0.24. 0.24 plus 0.24 is, that is 0.48 kg meter per second. I is equal to 0.48 kg meter per second. The exact answer for this question is, when the two balls of each mass 0.06 kg moving in opposite directions with the speed of 4 meter per second collide and rebound with the same speed, then the impulse in kg meter per second and imparted to each ball due to the other is, that is 0.48 kg meter per second. Kg meter per second.